Okay, hello. Today during the lecture, we talk about this, and some of you were missing, some of you were there either on Zoom or in the classroom, and most of you promised me to practice this. So let's talk about it. So this is part of the B series homeworks I'm taping. So what we're going to do is this. We're going to look at the different functional groups, right? We're looking at all these functional groups right now. And we have to learn how to convert them. This is really the key. In organic chemistry, this is what we do. We take one functional group, convert it to the other, and so forth and so forth. And we get tested on it. So we really need to learn that. This is the vocabulary of organic chemistry. So I'm going to do one piece of paper in front of you, then pause the tape. Pause the tape. Do it on the paper or on the computer. Paper usually is easier. Then go check my answer. So we're going to do this couple times. We're going to do this couple times. So we have to learn, guys. We have to learn. I'll put this away. Put the general paper here. So the general paper is this, right? So we have naming as the naming goes. So we have alkyne, alkenes, right? Alkynes, alkenes, alkanes, right? Then in the corner here we have ketones and aldehyde, alcohols, and alkyl halides. During the class and the map that we had before, we talk about that, how to go from an alkyne to alkenes and vice versa, how to go from the alkenes to alkynes, right? Then going from the alkanes, right, to alkyl halides, from alkyl halides to alcohols, and from alcohol back to alkyl halides, from alcohol to ketones, and from ketones to alcohol. Many reactions. Then we're going to go from alkene directly to alcohols, and from alcohols directly to the alkenes, from alkynes to ketones and aldehydes. Do we have some? I don't remember this now. Check my. No, going from alkynes to ketones and aldehydes. Okay, so repeat myself now. Alkynes, alkenes, alkanes, right? Alkyl halides, alcohol, ketones, and aldehydes. Nothing pretty, but we need to learn. We need to learn. So let's start with something very simple, right? So we're going to start with the acetylene. So I'm getting a paper here. So here's what I want you to put the paper in front of you and look at these reactions. So we want to do from acetylene, which is HC111CH. Make this straight. What we're going to do to this, reagent-wise, what we need to add to this to make a ethene, which is CH2, double bond CH2. And what we're going to do with ethane to make ethane, CH3, CH3. So this is the top of the list, right? Now I want you also tell me what to do with the acetylene to make into a aldehyde, CH3COH. Again, we talk about it. So the number of carbon is not changing in this practice. We have 1, 2, 1, 2. So what the reagents we need to do and use to convert an alkyne to an aldehyde, right? What reagent we need to use to go from a acetylene, a triple bond, to a double bond, from a double bond to a single bond. Now, at the bottom of the page, moving my paper a little bit, I want to convert this acetaldehyde. What should I do? How would I convert the acetaldehyde to ethanol, which is CH3CH2OH? Again, the number of carbons is the same. Now, what should I do with the ethanol that I made to go back to acetaldehyde? So we need two set of reagents here. Then I want to convert this ethanol now, right, to an alkene halide. So that would be CH3, CH2Br. So I want to go from here to here. And what should I do to go from this alkene halide back to ethanol? So down here, we're sort of having back and forth. And here, the same thing. I forgot about that. So I want to tell me how to go from 18, right? 18 back to acetylene. I forgot about that. Now I also want you tell me how to go from the ethylene, which is here, to this alcohol. So I'll use a different color. So we're going from ethylene to the alcohol. And how to go from the alcohol back to ethylene. Then from this alkene halide here, how would I go from alkene halides to ethylene? This is ethyl bromide. And then from the ethylene back to ethyl bromide. Many, many arrows. And my paper keep crooked. And the last but not the least, how to go from alkane on the top, ethene, to this. So many reagents, right? Many reagents. Many reagents. This is my page 2. So please put the video on pause. Stop it right now. Put a piece of paper in front of you, as you promised. And tell me all these reagents. Tell me all these reagents. Some of you might remember, some of you might not remember. Then go look at the answer. So I'm going to do that right now, but you promised me to put the tape on pause, redraw all these things on a piece of paper. That's usually easiest. Then come back. Thank you. Okay, I'm back. Hopefully you had some success and you remember some of these reactions. So let's start with the acetylene. So we have H, C, triple bond CH. And I want to know what reagent to use to make it ethylene, which is a double bond. So I'm going to work on the top part and then converting the ethylene to ethane, which is CH3, CH3. All of them have 2 carbons, so we're not increasing the carbon or anything like that. So to go from acetylene to ethylene, we had choices, right? We could add H2 hydrogen gas and some Lindner catalyst, which made it into a double bond. So that was option A. Option B was to use lithium metals or sodium metals and ammonia. So this is going from the top part, right? So we have from here to here. Now, how about going from here to here? Remember, we used bromine. So we had excess bromine. We had bromine. We had sodium amide and water. 1, 2, 3. So hopefully you remember this one. So going from here to here, we use hydrogen gas, Lindner, or lithium ammonia, going from alkene. We use bromine to make dibromide, sodium amide, and water. How about from here to here? So this was a very easy one. We remember we used hydrogen gas, and we used palladium or palladium as a catalyst. Now we haven't learned yet how to go directly from a alkane to alkene, but there are other ways. So at this point, we're not practicing that. But I also ask you to go from an alkane to an alkyl halide. So in this case, I have CH3, CH2Br. So we are just going from the alkane to alkyl halide. So we are going to use bromine. We learned this now. Bromine in peroxide. Or we can use bromine with light, which is HNO. So that provides us with the alkyl halides. Now I'm asking you to go from alkyl halides to an alcohol on the bottom part, which is CH3. I'll write it here. CH3, CH2, OH, ethanol. So to go from alkyl halides, it was easy. We only use sodium hydroxide, which is a SN2, or we can use water, SN1. So from here to here, we use water and acid, basically. So NaOH, which is SN2 reaction. Or we can use water, which is SN1, very slow. Now, how about going from alcohol to alkyl halides? We did that proposed lab, remember? Going from here to here. So we use HBr. Okay, so we have all the way we got from alkyne to alkene to alkane to alkyl halides to an alcohol, from alcohol back to alkyl halides. So now we're going to go from an alcohol to an aldehyde. So what should I do that? So let's look at that. CH3, 2 carbon units, COH, COH. To go from the alcohol to an aldehyde is oxidation. So it's an oxidation reaction. Many reagents we can use. We talk about it today. We can use sodium or potassium Dichromate, we learned this in general chemistry. Or we can use what a nickname for it is PCC. We learned that today. For a primary alcohol to an aldehyde. Again, going from alcohol to an aldehyde, we need to do the oxidation. It's an oxidation reaction. Now, going from an aldehyde to an alcohol, we need reduction. So sodium borohydride to water, or lithium aluminum hydride plus water. So we're going to reduce the aldehyde to an alcohol. Now, how would I go from the alkyne to an aldehyde? From alkyne to an aldehyde. Only from here to here. Remember, we use boron. So if I use boron, follow that by BH3, followed by sodium hydroxide, hydrogen peroxide. So I can go from an alkyne to an aldehyde. We haven't done the middle one yet, so we're going to use a different paper. Got busy here. But we did outside the circle, right? Outside the circle. You should have been done this already. If not, go back, do it again. Please. So let's go make the middle one. So the middle one, okay, we're back for the middle one. So we're looking at the alkene, which is ethylene here, ethanol. We had two ways to do that, remember? We either add water plus sulfuric acid, and that adds, remember, H and OH. The other way we learn, so this was Markovnikov. Oh, Dr. M, not Mr. M. Dr. M. Or something we did without Dr. M, didn't follow Dr. M, was first boron, followed by sodium hydroxide. So that combination made H and OH, which is here. 2 carbon units, 2 carbon units. Now, how did we go from alcohol to alkene? Alcohol to alkene. We use basically made OH a living group by adding acid. So typically we use an acid to go from an alcohol, same number of carbons, from an alcohol now to an alkene. So we usually use phosphoric acid or sulfuric acid. And we did that in one of the experiments, so E1 experiment that you're going to work on. So we did this as a lab. So let's look at the now going from an alkene, ethylene on the top, to an alkyl halide, which is this corner here. We did all the corner before, remember? Now we're doing the middle. So going from an alkene to alkyl halides, if I draw my arrow here, was HBr. So we did HBr by itself, and that was Dr. M. HBr plus peroxide or light. So we did from here to here. What did we do for alkyl halides to go to alkene? We didn't use acid. We use a base. So going from here, I'm going to draw my arrow this way. So we use a base, either sodium methoxide or a bulky base like O minus tertiary butoxide, potassium tertiary butoxide. Go from here to here. Many, many reagents. Many, many reagents. Many reagents. Hopefully you did all right. Now go back and practice. So we really need to practice. We really need to practice. We have to learn, guys, these things, right? This map. Alkane to alkene. Alkene back to alkyne. Alkene to alkanes. Alkanes to alkene halides. Alkene halides back to alkene. From alkene to alkene halides. Alkene to alcohol. Alcohol back to alkene. Alkynes to ketones and aldehydes. Thank you very much.